Myself Minmoy Das, Assistant Professor of W Department of Region Education and Research Foundation, Group of Institution. Today, I will going to discuss the topic of Thevenin's theorem. This is the subject of basic electrical engineering, which is taughting the all BTech first year students. So before the statement, I will going to discuss some introduction. So this Thevenin's theorem was invented by the Leon Charles Thevenin, and it is a mathematical law that simplifies complex electrical circuit for analysis, and it is also known as the equivalent circuit theorem, and also discuss the linear, active and bilateral circuit. So linear circuit means this circuit obeys the Ohm law. This is called the linear circuit. Next, active circuit means this circuit containing independent voltage or current source is called the active circuit. And bilateral circuit means the property of and characteristics of a circuit does not change with the change in direction of supply voltage or current. Is called the bilateral circuit. So a statement is any linear active bilateral DC circuit having several number of voltage source or current source with resistance can be replaced by a simple equivalent series circuit having single voltage source in series with Thevenin's equivalent resistance and load resistance. So VTH, this is the our Thevenin's equivalent circuit. This person VTH is the known as the open circuit voltage, or is known as the Thevenin's equivalent voltage, and this voltage across the load terminal, and RTH is called the Thevenin's equivalent resistance, and it viewed back into the circuit from the load terminal, and here RL is the load resistance. So when you apply the KVL as a current flow IL, so load current is the IL equals to VTH by RTH plus RL. So next, procedure of Thevenin's equivalent circuit. So first of all, we know the it does not know the VTH means Thevenin's voltage and Thevenin's equivalent resistance RTH. So first step, we calculate the Thevenin's voltage VTH. Suppose our this is the circuit, and this is the suppose a complex circuit as a because there is a resistance, 4 resistance, the connection is the series parallel, and there is a voltage source presence. So first of all, we remove the load resistance and find the voltage across this resistance. So in this position, suppose this circuit, this position voltage across VAB is the voltage across the R2, because if the current flow this path, current back into this path, because no current flow to the open side, this position is open, so no current flow this path, so voltage across this R2 is the Thevenin's equivalent voltage, Thevenin's voltage. So according to Thevenin's voltage, because this circuit Thevenin's voltage is equal to voltage across R2, and we apply the voltage divider rule of series circuit. So V into R2 by R1 plus R2. So we calculate the Thevenin's resistance. So in the first step of calculation of Thevenin's resistance, if the voltage source presence this source is removed by the, it is voltage is short circuited, means it is replaced by the internal resistance. And if the presence current source, this is the open circuited, or it is replaced by the internal resistance. And so in this our circuit, voltage source is present, so voltage source is short circuited. And looking from the load terminal, our load terminal is this portion, so looking from the load terminal, so across this circuit, this R1 and R2 is a parallel connection, and R3 resistance is the series with this. So Thevenin's equivalent resistance RTH is R1 and R2 parallel plus R3. And last step is the total equivalent circuit. So here is any complex circuit and there is a presence RL, load resistance. So convert to the simple equivalent series circuit which present the VTH is Thevenin's voltage, RTH and RL load resistance. So in previous RL is the known, but VTH and RTH calculation will show in the previous slide. So apply the KVL this loop. So load current is equal to IL equals to VTH by RTH plus RL. Now get to the example. Suppose our voltage source is 12 volt, 500 ohm, 100 ohm, 90 ohm and 50 ohm. This is our circuit. Question is find a current across the 50 ohm resistance using Thevenin theorem. So 50 ohm is the load resistance. This is the RL. So our calculation is 2 point is unknown. So Thevenin's voltage and Thevenin's resistance. So first of all, we calculate the Thevenin's voltage. First we calculate Thevenin's voltage. Open the, according to the explanation, open the load terminal RL and voltage across this terminal A and B. So there is a no current flow is in this portion, only current flow this path. So apply to the, so our VTH is the across this portion voltage, across the voltage V100, across the V100 voltage is the VTH. So Thevenin's voltage according to the we apply the voltage divider rule. The voltage divider rule is the total voltage into which voltage the resistance which I measured across the voltage measure by total resistance of series circuit. So voltage across that 100 ohm is the 12 volt into 100 by 500 plus 100. This is after getting this equation, then the calculation value is the 2 volt. Next we calculate the Thevenin's resistance. So here is a voltage source is present. So voltage source is short circuited or replaced by the internal resistance. So here 500 and 100 is the parallel connection and 90 is the series connection, because if the current flow this path, current is divided two portion. One is this is the, suppose this is the I, suppose main current is I and this is the I1 and this current is flow I2. So after this point I1 and I2 is sum and get the this I current flow. So this current is divided, means that this is a parallel circuit. So 500 and 100 is parallel and 90 is series with this. So after getting the calculation and getting the calculate this, RTH is the 173 ohm 173.33 ohm. So our unknown is like unknown is VTH and RTH required. So VTH is 2 volt and RTH is 173.33 ohm. We get this and apply this load current, apply the KVL. So I is 2 volt by RTH plus RL when the value is the 0.00895 ampere or 8.95 milliampere. This is the answer of this circuit of the Thevenin's voltage, Thevenin's theorem. So this is the application of the Thevenin's theorem is in power system and is a electronics portion and electrical engineering. And is mainly electrical used for load analysis, fault analysis, and designing circuit use. And this is the advantage of Thevenin's theorem. It is a simplify the circuit analysis because it's convert any complex circuit to simple series circuit. So this is a simplified circuit analysis. Next, reduce the need for repetitive calculation varying load condition. If we load is change, all other is same, but load is change, we put the RL value and get that load current. So this is the need reduce the need of repetitive calculation required, and easy to compute voltage and current or power or different load. For different load, we calculate the power voltage. So this is our Thevenin's theorem, and this video we discuss about the Thevenin's theorem. So thank you.